This is Britt Kessel with another example video. In today's video, I'm covering example 3 from section 6-5 in the SavvasRealize Algebra 1 textbook. The goal of this example is to compare two different transformations, but I'm not going to lie to you guys. I looked at example 3 and was like, cool story, bro. So I'm going to just kind of explain to you what they're saying on Savvas, but I'm going to be honest with you, I don't really understand the point of this example yet. So it says, how can you compare the properties of G given in the table? So we're trying to compare G to the properties of J, which is given on the graph. All right, so G is on the table, J is on the graph, and F is on both of them. All right, so they're both translations of F of some sort. So first they want us to start with the table. They want us to compare G to F. I'm going to write table here. So if I'm looking at from G to F, notice that they are adding 2 to each of these values. So because they're adding 2 to each of the values, each of the outputs, that's telling you that there's been some kind of vertical translation. Okay? So I'm going to write that here. Plus 2 to each value equals vertical translation. Which, Savvas doesn't really say that. All that they do is they mention the asymptote. Now remember, these graphs have asymptotes, right? They're horizontal and they go like this. And so if we have a vertical translation of 2 units, that means that our asymptote has been moved up by 2. And so that change in the asymptote is going to be changing the range of the functions. Alright, so the range of g of x starts at y equals 2, and the range of f of x starts at y equals 0. That's their goal there. Sorry, they say it's greater than 2 and greater than 0. So that was the point in looking at the table. So now step 2, now we're comparing the graphs. Okay, and they want us to look at the asymptotes of these graphs as well. So you could see the asymptote of f at y equals 0, and you could see the asymptote of j at y equals -1. So what's happened here is there has been a translation down. So the table, it translated up. This one translates down. And so now they want us to compare G to J. So remember G, I'm gonna sketch G in here. Why not? And by sketch I mean terribly draw, because I'm not good at it. Oh, we said it goes up 2 units. Here, I'm already messing that up, y'all. That would be here. With the asymptote here. There we go. That's my rough g of x right there. Okay, so here, now we're trying to compare the two changes that we saw here. Okay, so what they're saying is that because g was up 2 units from f of x, and j was down a unit, then the total distance between the two is 3. So you could see that between from anchor point to anchor point, that it's 3 units away. At least if I could draw right. And that's kind of their point there. Okay? So now let's look at their triads. So it says the graph of the function b is a vertical translation of the graph of a. And it has a y-intercept of 0. So what they want to know is how does the graph of this function, which is c, compare to the graph of b. So let's start by checking out some of these graphs. Okay, so I should have put a piece of graph paper on here, shouldn't I? That's all right. We'll get creative with our drawings, y'all. Okay, so here's my very fancy graph paper. So let's start by drawing a of x, which is 3 to the x. We're going to call that the parent function. So 3 to the 0th is 1. 3 to the first is 3. 3 to the second, way off in the middle of nowhere. And this is asymptotic to the x-axis. So here we are. That is a of x equals 3 to the x. Okay? So now it's saying b is some kind of vertical translation of the graph, and it has a y-intercept at 0. So for function b, it has a y-intercept right here at 0. So it's been moved down by 1. And so it becomes asymptotic here at -1. Ooh. So this is b of x. So if I were to write the equation for this where it's been translated down by 1, I would write that as 3 to the x minus 1, and make sure that minus 1 is on the same base as the base of the exponent. And then graph C is 3x plus 1, so that plus 1 is a vertical translation that moves it up by 1. So if I'm trying to compare graph B and graph C, you can now see that there's 2 steps of difference. So graph C is translated up 2 units from graph B. Alright, so then this last one, they want us to compare these two graphs. So what I did was actually put them on a Desmos graph, and you could just see right away that they have a difference of 7. And that's because this is shifted down 3 from the parent function, and this is shifted up 4 from the parent function. And so because they're going in opposite ways, you add those, and there you have it with your distance. So there we have it. That is comparing 2 different transformations. Until next time.